So today we are going to be talking about rational functions. And we've talked about the reciprocal function, and we did the transformations of those. But we're going to be looking at ones that have a little bit more involved in them. There's going to be multiple asymptotes instead of just one. And so today we're focusing in on three key ideas: the intercepts, the points of discontinuity, and which we're going to talk about the domain because of this, the way it affects the domain, and the vertical asymptotes, which is a form of discontinuity. And so step one, you must always factor the numerator and denominator, because without those two things factored, you will not be able to go on to the next steps. So to find a removable discontinuity, you're going to take and see. So like if I'm going to go ahead and give you one that's factored. And so a removable discontinuity will be one of these. See how we can cancel these two factors? You would actually set x minus 2 equal to 0. And at 2, when x is equal to 2, we'll have a removable discontinuity. A non-removable discontinuity will come from your denominator. So you'll set after everything's been canceled, whatever factors are left in your denominator, you'll set those equal to 0. And that is where you will have a vertical asymptote. So x equals -3 will have a vertical asymptote. That means the graph will get close to but not cross that line. And we'll talk about graphing later. We're just finding all the key features first. And today we're working on these ones. To find your x-intercepts, you'll take so this one, when we reduce it, it'd be anything that's set up here in your numerator after you reduced it. So in this case, 1 equals 0. Well, that's never going to happen, so there is no x-intercepts. And we'll look at some that actually do have one here in a little while. And the y-intercept is, again, at this reduced fraction. Don't go back any further. You're going to put a 0 in, so I'll do 1 over 0 plus 3. So my y-intercept is when x is 0, y is 1/3. There is never more than one y-intercept. There can be more than one x-intercept. So let's work through an entire problem from start to finish. So step 1 said we need a factor. So I take this denominator and I'm going to factor it. And so that means x squared 3. What multiplies to give me 3x squared, that will add to give me -4x squared. And that's going to be -3x and -1x. And we factor it. And so this can be rewritten as x plus 3 divided by x minus 3 times x minus 1. So here is my factored solution. And so this is going to be what I use to help create each of my other things. So let's go ahead and find our intercepts first. Let's find our x-intercept. And so to find our x-intercept, we're going to take our numerator and solve. And so x equals -3, because that's when I subtracted 3 from both sides. So our x-intercept, x is -3, y is 0. So our x-intercept is -3, 0. Now we're going to find our y-intercept. That's where I take my reduced fraction, so nothing got to cancel out on this one. And I'm going to replace all my x's with 0. So y equals, oops, I forgot to put the y equals on this problem. 0 plus 3 divided by 0 minus 3 times 0 minus 1. So that simplifies to 3 divided by negative 3 times a negative 1, which is 3 over 3, which is 1. And so my y-intercept is at, I put x was 0, y ended up being 1. So there's my x and y intercepts. Now, so we got this taken care of. We're going to find our points of discontinuity, which is going to include the vertical asymptotes. So I look to see any canceled factors. And there were none. So that meant there are no holes or removable discontinuity. That's just where a gap, where the graph would actually skip a number. It could not actually be at that spot. And then the last thing that we're going to be looking at is we're going to be finding our vertical asymptotes. And so our vertical asymptotes, I use VA to stand for vertical asymptotes. That's when I set my denominator after it's been factored equal to 0. So x minus 3 times x minus 1 equal to 0. And so my vertical asymptotes are going to show up when one of these two factors is 0. So x minus 3 equals 0. So x equals positive 3 is one of my vertical asymptotes. X minus 1 equals 0. So x equals positive 1 is my other vertical asymptote. And so to summarize and see what everything fills in from this, my x-intercept was at negative 3, 0. My y-intercept was at 0, 1. My vertical asymptotes were at x equals 3 and x equals 1. And it doesn't matter which one you put first. And then I didn't have any holes, so I don't have anything on that. The last thing I need to do is identify my domain. Oh, what am I writing? And all real numbers except when x is equal to 1 and 3. And these numbers that accept are your vertical asymptotes and from your canceled factors. So those are the two things that will be accept. So let's do two more together, and then I'm going to let you do one on your own. So again, we're going to go through the same process. We're going to find it factored first. So what multiplies to give me 1x squared that adds to give me 0? Well, it's not possible, so it's not factorable. So there are no real factors in the denominator. So there are going to be no vertical asymptotes. And there are going to be no points of discontinuity. So that means our domain is going to be all real numbers. Because we cannot factor the denominator, that means there's no terms I can cancel. Now, if it's already factored out, look to see if there's points that we can cancel and set the denominator equal to 0. So the domain, in this case, is all real numbers. But we still have to find our x-intercepts and y-intercepts. So x-intercept comes from setting your numerator equal to 0. So x minus 5 equals 0. So x is equal to 5. So that means our x-intercept is at 5, 0. Y-intercept, remember, is going to come from putting a 0 in for all of your x's. And so y equals 0 minus 5 divided by 0 squared plus 1. So negative 5 divided by 1. And that gives us 0 in for x and negative 5 for y, because that reduces to negative 5. And so my x-intercept is 5, 0. My y-intercept is 0, negative 5. And on this one, there were no points of discontinuity or vertical asymptotes because the denominator was not able to be factored, and that denominator could not cancel with anything in the numerator. Now, if it wasn't squared, I would set that equal to 0, but since it is squared, I have to go with that. So let's go on to the next one. Okay, so step 1, we're going to go to where we're factoring our numerator, because that's the one that has a squared term in it, so that's the one I know I need to factor. And so I'm going to use my box to help me factor. X squared goes here, negative 4 goes here. So what multiplies to give me negative 4x squared that will add to give me negative 3x? And that would be negative 4x and a positive 1x. And when I factor that, an x and a 1 come out of the top, an x and a negative 4 come out the side. And so I have x minus 4 times x plus 1 over x minus 4. And so let's go ahead and cancel what can cancel. So this x minus 4 and the x minus 4 can cancel. So that's going to give me that point of discontinuity. That's going to give me that removable discontinuity that's also called a hole. So that's going to come into play later. When I simplify this simplifies down to x plus 1. So y equals x plus 1. And that's what's going to help us with finding our x and y intercepts and for finding our domain and vertical asymptotes. So first off, let's find x-intercept. So x plus 1 is over 1. So that's our numerator. So x plus 1 equal to 0 and solve, and x equals negative 1. So our x-intercept is at negative 1, 0. Our y-intercept is after we place the reduced fraction. In this case, that reduced fraction is just that x plus 1 equal to 0. So 0 equals x plus 1. Excuse me. I said that backwards. I was just talking about x-intercept again. That's when we set x as 0. So 0 plus 1 is equal to y. So y is equal to 1. And so our y-intercept is 0, 1. And then this time we do have a hole because we do have a canceled factor. And that's that x minus 4 that got canceled. And so our hole, our removable discontinuity, is x minus 4 equal to 0. And so our hole is going to happen at x equals 4. So our hole was at x equals 4. And our vertical asymptotes, we had none that we have no holes in the denominator, or nothing left in the denominator. So there are no vertical asymptotes. And so we're going to summarize this by saying we have an x-intercept at -1, 0. We have a y-intercept at 0, 1. We have a removable discontinuity at x equals 4. And we have no holes. So that means our domain is all real numbers except, I can actually write, at x equals 4. And so we're going to get you to do one on your own. So again, remember, first step is you want to factor that denominator. And then you want to cancel anything that can cancel. Then find your x and y intercepts and your vertical asymptotes and any removable discontinuities. So in this one, there were no x-intercept because there was nothing in that numerator that can be set equal to 0. Our y-intercept is 0, -1/16. We had no holes because there's nothing that could cancel, but we did have two vertical asymptotes at 4 and -4. And so our domain was all real numbers except for 4 and -4.